Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface. And in the previous lectures, we looked at the overloading and overriding native methods, and we looked at a lot of details about them. We also looked at the static native methods and how the overloading is different for them. And now the question here is that once we have a class hierarchy, so we have a superclass and a subclass, and both of them have native methods, and some of the native methods might override each other. Then the question is, where do we load the native library or the dynamic library into memory? Do we load it in the superclass or the subclass? So where is the best location for loading that? Now, what you need to understand is that JVM loads the entire superclass hierarchy when loading a subclass into the memory. So we said that we always prefer to load the dynamic library in a static initializer in the class. But then when we try to instantiate a subclass or access a static method of that class, JVM loads that class into the memory, all right? But if the subclass has some superclasses, JVM also loads all the superclass hierarchy before loading the subclass hierarchy, all right? And then the static initializer is executed only once, and that's when the first time a class is loaded into the memory, all right? So this is one of the important things that you have to keep in mind, that the static initializers are only executed once, and that's the very first time a class is loaded into the memory. Note that the loaded into the memory is different from instantiating a class, right? You might not instantiate a class, but the class might still be loaded into memory, and that's the case when you try to access a static method of a class, right? In order to access it or execute a static method, that class has to be loaded into the memory by JVM. And that's when the static initializer will be executed. So accessing a static field or method also loads the class into the memory, and instantiating a class for the first time, i.e. using the new keyword to instantiate the class, also loads that class into the memory. So it's not just when we instantiate a class it gets loaded. Even when we access a static method or a static field, the class will be loaded into the memory, all right? So one of the important things here is that when we have static initializers both in a superclass and a subclass, then you have to be aware of how the order of execution works, right? So the order of execution when loading a class into the memory, the entire inheritance hierarchy is loaded. So, and again, a static initializer are executed even before the constructor, because the constructor is executed when you instantiate a class. But you might not even instantiate a class, you just access a static method or a static field, and that's when the class is loaded into the memory and the static initializer is executed. So if I have a subclass and superclass, and the order of execution is something like this. First, the static initializer in the superclass is executed, because the very first time we try to load the subclass, the superclass is loaded into the memory, and the static initializer is executed. And then the static initializer of the subclass is executed. So the constructor has not been executed yet, right? First, the static initializer of the superclass, because the superclass is loaded into memory, and then the static initializer of the subclass, because the subclass is loaded into the memory. Now we get to the execution of the constructors, and we know that the Java compiler always adds a call to the superclass constructor as the first line of the subclass constructor, right? So the superclass constructor is being called and executed. And the thing about the constructor is that if we have an instance initializer in the class, the compiler copies that code inside the instance initializer into as the first line of the constructor, right? So when the constructor is run, the instance initializer of the superclass is executed. So always copy the beginning of the constructor. So if we have an instance initializer in a class, that code is call is copied to the second line. So the first line is always the call to the superclass constructor. The second line of a constructor is always the code inside the instance initializer. So if the superclass has an instance initializer, it's going to be executed. And after that, any other code that is inside the superclass constructor is going to be executed. And then after that, the instance initializer of a subclass is executed. And then eventually any other code that is inside the subclass constructor is being executed. So if we want to load the dynamic library into the memory, it's best to put it in the superclass static initializer, because even if we instantiate the superclass or subclass, we are sure that that dynamic library is loaded into memory. I mean, there are also other ways that we discuss as we progress in the course, but this is the easiest way to make sure that if we have a very long class hierarchy, for example, here I have animal at the top, and then mammal, and then cat, right? A cat is type of a mammal, and a mammal is the type of animal. So if I have a dynamic library associated with these classes, it's best to load it in the instance in the static initializer of animal, which is the superclass of all of them, right? So let's head to Eclipse and try to have a closer look at this execution, at this order of execution. So I'm going to create another package in our project. Let's create a new package and call it test3. And here I'm going to create a class called animal, and I'm going to create another class called mammal, and I'm going to say that its superclass is animal. Okay, so I have a mammal, which is a type of animal, so extended. So let's add stuff. So let's add a static initializer. Let's just say sysout inside animal static initializer. All right, and then let's add a so this is called a static initializer, and this is going to be executed only once, and that's when the very first time the animal class is loaded into memory. And then we have instance initializer, and it's very similar to the static initializer. So basically it's a code block. A code block is specified by 2 curly braces. So it's basically a simple code block, which is a code that is between some curly braces or curly brackets, but it doesn't have the static keyword in it. So let's just copy and paste this inside animal instance initializer, and then let's also give it a constructor public animal, and let's say basically inside animal constructor. All right, so we can copy and paste all of these into the mammal, and this should be mammal. All right, so let's see what happens. So I'm going to create another class. Let's call this test and have a main method. And in the main method, what I'm going to do, I'm going to instantiate the subclass, which is mammal in this case, mammal. All right, so let's say mammal, or maybe, yes, we can just say mammal. A cat is new mammal. All right, so let's see what happens when we run this. All right, let's have a look at the order of execution. Animal was the superclass, right? So the very first thing that happens here when we instantiate a mammal, note that it doesn't matter if the type of the cat is mammal or animal, because it doesn't make any difference. We are instantiating a mammal object, right? A mammal class. So it doesn't matter if the cat actually refers to a mammal or animal. The results should be the same. All right. So, but let me just use the mammal case here. So the very first thing that happens when we instantiate mammal class is the JVM loads the entire class hierarchy into memory. And this class, mammal, only has one level of hierarchy, which is animal, right? So the very first thing that happens is that before even loading the mammal class, the JVM loads the superclass, which is the animal, into the memory. And when the animal is loaded for the very first time, this static initializer is called. That's why we have this animal static initializer. And after that, the instance, because after that, what happens here is that when the animal is loaded into the memory, then the mammal class is loaded into the memory. So the instance initializer of the mammal is called or executed, right? So this is happens. Okay, maybe let's see, animal static initializer inside. Yeah, so I made a mistake here. Inside the mammal static initializer. So let's run this one more time. All right. So again, static initializers are executed when the class is loaded into the memory, even before any instantiating happens or any call to any constructor happens. So these two are loaded into the memory or executed, the instance initializers. And then because we're creating a new object, we're instantiating, the constructor of the mammal class is called, right? And then we know that in the constructor of a subclass, the very first line is the call to the superclass. So the constructor call to superclass, which is the animal constructor. So this line doesn't get executed until we complete execution of the constructor of the superclass, which is animal, right? And we know that in the constructor, if there is no other superclass, the next line is basically the instance initializer. So what happens here is that the compiler copies the code inside the instance initializer to the second line. So the first line is always a call to the superclass. In this case, it's basically object class, and the object constructor doesn't have any code inside of it. So we don't need to specify that. And after that, the second line is always the code inside the instance initializer. That's why after the static initializers and the call to the superclass, we see that the instance initializer of the superclass, which is the animal class, is being executed, right? And then after that, we again, we are still in the call of the animal, which is the superclass constructor. So the other line of code inside the constructor of the superclass is executed. And now after that, we return again. So we finish the call to the constructor of the superclass, and now the second line again is instance initializer for animal, for mammal in this case, right? So then this code, this line of code, which is inside the instance initializer of the mammal class, is executed. And finally, the other lines of code inside the constructor of the mammal is executed. So you see this, the chain of events. First, the class, all the classes in the hierarchy have to be loaded into memory, which means all the static initializers must be loaded. And then the call to the superclass constructor, which may also invoke any instance initializers in the superclass. And then the call to the subclass constructor, which may invoke any instance initializer in the subclass. All right, so this is the chain. So as I mentioned, the best way or the best place to load a dynamic library into the memory, if both of the superclass and subclass have native code, is to load it inside the superclass static initializer, system.load library, and some name. So native C was the name of our binary here. If I go to the C perspective, we have this native C in the JNI, right? And once I do that, it this library is loaded regardless of whether or not I create a subclass or superclass. Now in this case we can actually instantiate the superclass, so it's not an abstract class. Okay, so if I execute this, we see that the static initializer of the animal is being executed, and then the instance initializer, and then the constructor. Now if I do it one more time, what you see here is that the static initializer is not run twice, it's only run once, the very first time a class is being loaded into the memory. So this is for the first instantiation. The second instantiation doesn't have this static initializer. It has only the call to the constructor, which runs any code inside the instance initializer and then the constructor. All right. So the static initializer is only loaded once, or only executed once. So our native library here is only loaded once, regardless of how many mammals or animals we create or instantiate, right? Now the other thing is that we don't necessarily have to instantiate something. If I have public static void func, something like this, and let's even call it native, or for now let's just leave it a regular method. All right, public static void func, this is a static method. So even if I don't instantiate mammal and then just say mammal dot func, so I'm calling a static method inside this class, can you guess what happens? So here it's very first time that the mammal class is being accessed, or some static method. So JVM has to load this class into memory. So the static initializer of the mammal is going to be called. And because this mammal has a superclass, the static initializer of the superclass is called even before the static initializer of the subclass is being called. So we will see this call to the static initializer of the animal first, and then the static initializer of the basically this mammal class. And maybe let's also give a body here for the static method, mammal static method, and finally the static method is being called. So let's run this. So the static initializer of the animal, which is the superclass, and then the static initializer of the subclass, because these classes are being loaded into the memory, and eventually the method is being called, right? No call to the constructor, and also no execution of the instance initializer, because the instance initializer only is being executed when we have a call to the constructor. Okay, so I hope you understand these differences. And again, accessing a static field, a static method, or even a static field. So public static int, let's call this name, equals, or maybe ID. Let's call this 1. Okay, so now instead of calling a static method, I'm going to have a call to this ID. And again, basically, so we have to assign it to something. We are accessing this field, a static field, so JVM has to load this class into memory, and before loading this class, JVM loads all the super classes. So again, we should see basically the same thing here. Execution of the static initializer of animal, a static initializer of the mammal, and then we access this ID. All right, now if I access this ID for the second time, you see that we don't see the static initializers twice, we only see them once, right? Because the static initializers are only executed once, the very first time a class is loaded into memory. Same thing with the static method. So if I call this static method func twice, the static initializers are being executed only once, right? So the very first time I call this func, we have these first 3 lines, and the next time we call it, we only get this extra line which says that the static method in mammal was accessed or executed. So this is a good thing because having a static initializer guarantees that the library is only loaded once. We don't load it twice, right? I guess the JVM won't have any problem with loading a library twice, but there's no point in loading a library twice. I mean, it's fine, it still works fine, and the library is loaded twice, but if it's a big library, then it takes time, right? So we don't want to load a library twice, which is a repeated thing to do. So we want to avoid it, so we just call it in a static initializer. So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.